Hey everyone, so today we're going to work on analysis with the first and second derivative. So kind of connecting f prime, and f double prime graphs. There's not going to be anything necessarily new since we talked about points of inflections and concavity. This is just really connecting it, like what does that look like on each of the graphs. So the first thing I want you guys to look at is kind of the connection here with points of inflection and concavity. So we have concave up on, this is our f of x graph, so we're looking for that cup shape here. Okay, and you'll notice, I'll do this in red here, this will be concave down. Okay, and that change in concavity is our friend's points of inflection, right? So we're going to say this is, we call this point A and point B, our 2 points of inflection. Okay, well, what does that look like on, let's go actually all the way to the f double prime graph. So f double prime, okay, when we're concave up, what do we know? Well, we're concave up, that means f double prime is positive, and that would be over here as well. So it's above the x-axis, and when f double prime is negative or concave down, I'm below the x-axis. Okay, and notice that those points of inflection are the x-intercepts because that's when f double prime is 0. So here's still A and B, and you can see kind of those dashed lines connected through the whole graph. All right, now the only little difference here, and we're going to write that down in a second, okay, is what about an f prime? Okay, what does concavity look like in f prime? Well, if f double prime is positive, that means f prime is increasing. F prime is increasing. So it's actually going to be the positive slopes, if you want to write that down. The positive slopes are when f prime is increasing. That's when we have concave up and down, or concave up, excuse me. And then when we have negative slopes, okay, or f prime is decreasing, we have concave down. Now again, you'll notice we actually have the local maxes and mins of f prime are our points of inflection A and B. So try to notice how those all connect, and we're going to write that down right now so that we're not missing that connection here. So I'm going to write pretty small because I'm going to write a couple things for each graph. So first of all, f of x is concave up on 0 to A, union B to infinity, which again, that really means that f double prime is positive. Okay, well, what does that mean for f double prime? Maybe I'll write that next. Well, since f double prime is positive on 0 to A, right, that's where we highlighted green here, 0 to A union B to infinity, that really means the original graph is concave up. Okay, so those two connections really big. Make sure you're okay with f of x and f double prime, how those connect. Now, how about this middle one? Okay, I think it's important that we connect f prime as well. So what does that mean for f prime? That means f prime is increasing. And what does increasing mean? That means positive slope, right? So for the second graph here, since f prime of x is increasing, positive slope on this graph, on 0 to A, union B to infinity, that tells us that f double prime is positive. Okay, so those are the connections I want you to make so far. Concave up in the first graph looks like concave up. In the second graph, it's positive slope of f prime, or when is f prime increasing. And in the last one, it's just when is it positive, above the x-axis, when is it negative, that'd be concave down, below the x-axis. Okay, and again, it's because f double prime changes signs. The slopes of this graph are f double prime. F double prime is positive, f double prime is negative, f double prime is positive. Okay, and here it's our concavity. F double prime is positive, concave up, f double prime is negative, f double prime is positive. Okay, so let's write down a couple more things here. What about concave down? I'll write this in red here to match. So we're going to pretty much write the same sentences, but now talk about concave down. So just so you guys have a really nice reference here, when you're studying, you'll have kind of this red dashed rectangle again that gives us that important info. So f of x, we already highlighted this, was concave down on A to B, between A and B, okay, which tells us that f double prime is negative. Okay, and again, for this one, f double prime was negative. It's below the x-axis on A to B, which tells us that f of x is concave down I'll put CC down if that's okay for concave. And what else does that tell us? That tells us that f prime is decreasing, or f prime has a negative slope. Okay, so since f prime of x is decreasing, falling from left to right, decreasing on A to B, that tells us that f double prime is negative. Okay, and the last thing I want to point out to you guys, if you're done writing all that down, pause if you need to. Really important info here are those POIs. I'm actually going to put them in blue really quick. Points of inflection, again, change in concavity. Here, it's still when f double prime changes signs, but that's going to be when they change slope, or when f prime changes from increasing to decreasing. Okay, and then here, f double prime changes signs when it goes above and below the axis, because this is the f double prime graph. So let's write that down here as well. So f of x has POIs, again, that's point of inflection, if that's okay if I use that, at x equals a and b, which tells us that f double prime changes signs. Okay, AKA in this picture, it changes concavity, changes from concave up to concave down, or concave down to concave up. All right, here's a little bit different of a scenario, okay? We want to talk about, what does f prime have? Well, f prime has a relative or local max, okay, at x equals a. Why does it have a local max there? Because f double prime changes signs. And again, what does that mean? If f double prime changes signs, that means f has a point of inflection. The original graph has a point of inflection. All right, very similar sentence. How about B? What's happening at B? We have a local min, or a relative min. F prime has, again, it's not on the original graph. This is on f prime. So f prime has a relative min at x equals b, which tells us that f double prime changes signs. It goes from negative to positive, which gives us that f has a POI there, sorry, point of inflection. All right, and the last one we want to talk about is at, in our f double prime graph, what do those x-intercepts represent? As we know, they're points of inflection. So how would we justify that? We would say f double prime changes from, and I'm actually going to branch off here because there are two different situations. We want to mention specifically what's happening. So when it changes from f double prime is positive to f double prime negative, okay, at x equals a, versus it changes from f double prime negative to f double prime positive at x equals b, okay, then we have a POI, point of inflection, at x equals a and b. Okay, so I'll give you guys a second to write that down. Remember, we do want to specify the sign changes, positive to negative or negative to positive. Okay, so definitely really important rectangle up here, so make sure you got that down. We're actually just going to try example 1 and work through some stuff we already know and add in some of the second derivative stuff. So take a look. We are looking at a graph of g prime, so very important. We're looking at the derivative graph, and it has a semicircle and 3 line segments. So the first thing we're going to do is part A. It says, where is g of x increasing? So g of x increasing means g prime is positive. Okay, so it's definitely something to look out for, and just being able to kind of translate that. So where is g prime positive? It's positive here and here. Now, this is going to come up a couple times. The slope of this line is -2, if you guys were to count here. So this point right here is going to be 4.5 exactly, but you could calculate that by looking at the slope. We don't want to just guess it's 4.5, we would actually calculate it. So anyways, from -2 to 4.5, since, and we actually already wrote our justification, I can just scooch it over, since g prime is positive, that's when g of x is increasing. All right, how about points of inflection? Okay, well, what does that look like? Well, possible points of inflection, okay, we want to know if it changes sign. So first we're going to have to write down possible ones. Possible POIs of G, okay, are critical numbers of G prime. All right, aka we're looking at some corners where G double prime, so it's where G double prime changes signs. Okay, that's going to be one of the main features, and G prime changes from positive to negative. You can think of it that way, from increasing to decreasing or decreasing to increasing. All right, so what we're looking at here are where, again, points of inflection. Okay, this is where G double prime is 0 or undefined. Okay, what is that? Undefined, there we go. So G double prime is 0 or undefined. So take a look at this graph. G double prime is the slopes of G prime, right? This is G prime. So at this corner, at this 0 slope, at this corner, those are the possibilities. I'm going to erase this red here. Those are the possibilities for points of inflection. So I'm going to write those down. The possible POIs are at -2, 0, 2, and 3. And that's because the slope at those points, which is G double prime is either 0 or undefined. Now, we also have to change signs. So notice here, we have G double prime is positive. Okay, it's increasing. And then we also have G double prime is still positive, right? Because that's the slope of G prime. So a little bit hard to connect here. All right, then on this side, we have, this would be a negative slope, aka G double prime is negative. This would be back to positive slope. G double prime is positive. Okay, and this guy I'm gonna make into that pink color because this is also G prime is decreasing, aka G double prime is negative. So which one of these are actually points of inflection? G double prime has to change signs. So does it change signs at -2? No, it goes from G double prime positive to positive. G prime is still increasing. Okay, how about at 0? Yes, it changed from G double prime positive to G double prime negative. Okay, how about at 2? Yes, it changed from negative to positive. And at 3, yes, it changed from positive to negative. Changed from blue to pink in the picture here. So we're going to write those down. Okay, so there are points of inflection, POI, at, okay, I'm going to categorize them a little bit. So x equals 0 and x equals 3, that was because or since G prime changes from G prime increasing to decreasing. Okay, you could also say here, sorry, there's not a lot of space, G double prime changes from G double prime positive to G double prime negative. Okay, and my other sentence about x equals 2 is going to be almost exactly the same, so I don't want you to get confused on that. So there's also a POI, point of inflection, at x equals 2, since G prime changes, sorry, there's not a lot of room, guys, from G prime decreasing to G prime increasing. Or again, you could say G double prime negative to G double prime positive. Okay, so that's how we would find our points of inflection on a G prime graph. We're actually looking for where the slopes change, or like those maxes and mins, or any type of undefined slope. Those corners are also a candidate. All right, so we're going to finish up here with, let's actually go to part D. It says, where are we concave down? Okay, concave down, again, you're not actually looking for that shape. You're looking for, concave down means G double prime is negative, and that also means G prime is decreasing, right? These are the same meaning here. So we already wrote this down, but G prime was decreasing from 0 to 2 and from 3 to 5. Okay, so from 0 to 2, union 3 to 5, since G prime is decreasing, therefore G double prime is negative. Okay, just like those things we were looking for. Okay, so last two things we're going to talk about are tangent lines and critical values like max, min, and neither. So this should be a review right here. Okay, so take a look at identifying the critical values, classify as min, max, or neither. So I want you to take a step back and think about what are max, min, and critical points for a G prime graph. Those are your x-intercepts, right? So I'm gonna actually, maybe actually we could drag this up, that might be helpful. Okay, kind of save that, maybe that will be helpful later for you. Okay, but we're gonna change it up to, what are my x-intercepts? I have -2, I have 2, and I have 4.5. And all I'm looking at now is, does G prime change signs? Okay, well, G prime was below the x-axis, now it's above the x-axis, so this is a minimum, okay? G prime was above the x-axis, and then G prime was above the x-axis, so this is neither. And finally, this was at 4.5, if you guys remember. G prime was above the x-axis, and now it's below, so it's positive to negative. This would be a maximum. So we're just gonna write those justifications down, and we should know how to write them from our prior lives here. Okay, so x equals -2 is a relative min of g of x, since G prime changes from negative to positive. Okay. X equals 2 is neither a max or min of G, since G prime doesn't change signs. Okay, and x equals 4.5 is a relative max of G, I guess I'll say that, of the original graph, since G prime changes from G prime positive to G prime negative. Okay, so take a pause if you need to. Those are justifications we've seen many times, so I hope you're feeling okay about that. And the last step we're going to do is this tangent line. Okay, so very last problem here, we're going to talk about a tangent line. It says if G of 4 is 2, so that gives us y minus 2 equals some slope times x minus 4. Okay, write the equation of the tangent line at 4. Well, to find this, hopefully we know this is G prime at 4. Okay, and the nice thing here is that G prime at 4, if you go take a look, we're at 4 right here. This point, okay, at 4, that is G prime of 4, and that point is 1. Again, I know that because the slope is -2 here. Okay, so since that's the slope, we don't have to look for the slope of this. A common mistake, people might say it's -2. G double prime is -2, but G prime itself, this is the graph of G prime, so it would be 1. Okay, so here's my line. I'm actually done writing the equation. The second part, though, is a little weird. It says, it was something we haven't talked about. Is it above or below the curve? Okay, here's how we're going to figure this out. We're going to look at concavity. Okay, concavity meaning is it concave up or concave down? So at x equals 4, what are we doing? Well, G double prime is negative. Okay, I know that because G prime is decreasing. That means it's concave down, the original graph. G is concave down. So it looks something like this, right? Of some sort. We don't know exactly what it looks like. So if I drew a tangent line here, okay, try to draw a tangent line, what's going to happen? That tangent line, no matter where I draw it, is always going to be above, okay? So it's going to be above because so what we would write here, x equals 4, G of x is concave down since G double prime is negative. So the tangent line is above the curve. And again, you're thinking on the original graph, something like this. That tangent line would be above the graph. Think about it, if it was concave up, our tangent line would be below. So that is it, guys. Take a look. I'm sorry to smush so much information into one little space. Hopefully you're feeling okay with those connections. And I always think this is pretty difficult, connecting G, G prime, and G double prime. So take a second and pause if you need to. We are going to continue the second page in class, and thanks so much for watching.